So if I gave you a triangle as a gift. Sure. So let's say here, the right triangle, it's got to be a right triangle at the moment because that's what all our trig stuff is built on. And I tell you, this is 11, this angle is 37 degrees, and I want to know how long this side is, right? So let's make this into a real physical problem. This is a building. The ladder, there's a ladder here that's leaning against the building. I know it hits the building at a point 11 feet up, and I want to know how long the ladder is, right? That sounds a lot like the buying 60 cantaloupes and nobody asked me, so like, you should know how long the damn ladder is, but let's just go with it. Right, this is a real physical problem. At this moment, you all should be able to determine which trig function relates what I know with what I don't know, right? And what I want to know is more important. Do I know the length of this side?
No.
Do I want to know the length of this side?
No.
Yeah.
I don't give a shit about the length of this side, correct? I mean, you might. I'm not going to take that away from you. If you do, you're like, come on. But as far as the problem's concerned, I don't care about this side. Does everybody see that? So I wouldn't use cosine, for example, right? I wouldn't use tan, whatever. So I'm given this side, I'm given this angle, and I want to know this side. What trig function relates those sides?
Sine or cosecant?
Sine. Or cosecant, but let's use the basic, right? The three known ones. So this would be sine of what?
37.
37 degrees equals?
11 over L. L over 11.
Ooh, got the ascension. So remember,
Rock, paper, scissors,
It's
first.
Y over R. So it's
y over r. There you go. 11 over L. Let me stop for a minute. The first step is just applying the basic idea of trig functions, the ratios. So I picked the correct ratio based on the sides I want to know and I know, and then I set up the ratio. And now after this, it's purely solve and then plug in the calculator. So I want to solve for L, correct? What do I do in any algebra problem when the letter I'm trying to solve for is on the bottom?
Divide the letter and divide.
Multiply by the letter, yes, because that'll free it. If I multiply by L, I get L sine 37 equals 11, and one more step and I got L by itself.
Divide by
Divide by sine.
Good.
37.
Shortcut then would be just to switch these, you guys see
Yeah.
that? So it's divide. Real quick, I'll say something on the side real quick. And when we get this done, if you have a calculator, did I bring any? No, I'm so smart. Can you, I was gonna bring some for those who don't have one, but if you do have one, can you do that in your calculator? Because 37 degrees, is that an angle you're supposed to know anything about?
No.
It is? Oh. No, okay. I was gonna say, don't memorize sine of 1 degree, sine of 2 degrees. What are the only angles you're supposed to know?
30, 45,
30, 45, 60,
90.
0, 90, yes? Because then all the other quadrants is just what sine is. If you guys kind of with me? That work is not difficult. It's built on trig functions and what they mean, but even that definition is just ratios of sides of triangles, right? Okay. What do you guys get? Anybody plugging this in? Make sure you're in degrees, right? Everybody should be.
18,
What do you get? Sorry?
278.
I'm sorry, say
18.278.
18.278.
78.
Okay. And I would tell you how many places to round or whatever. You guys got it with me? Because I'm sure it keeps going.
So you want us to go 3 decimal places?
Yeah, I would tell you how many places to go. Yeah.
Okay.
I like 2 or 3 in general, but
And for the homework too? So if
I don't know if the homework, sometimes they tell you to round to the nearest whatever, but a lot of times they don't.
Yeah,
So
they don't.
just give me 2 or 3 places, that's plenty.
Okay.
2 or 3 places, give me 2. Is that all right? Why does that make sense? What should be the longest side in the triangle? Which is the ladder length, right? And that is bigger than 11 at least, so at least on that, if I got 9 here, I know I made a mistake. I don't circle that shit. I go, what did I do wrong? Maybe most of the time it's just you set this up the wrong way. Does that make sense? Yeah. So be able to step back from the problem, just see, does it make physical sense? The ladder should be the longest piece of this triangle. Yeah. me stop for a minute. Anybody get a different answer than that? That tried that out, you guys all? Okay. So, that's a problem we can currently just do, right?
Just to find a side.
Huh?
Just to find a side.
Yeah, as long as I'm given an angle and one other side, I could actually do what's called solve the triangle. I think we did that once. I could get all the sides, I could get all the angles. Do you guys agree I could get this side if I wanted to?
Yeah.
Y'all, I can totally get that angle easy as shit, yes? Anybody, what's that angle?
43, no, 53.
53, right?
Yeah.
That's already 90, these have to make 90, so that's the complement, is 5311, kick ash. Okay. Alright, so, let's talk about a problem we can't currently do.
I have a quick question.
Yeah,
So, just simple one. Why did you draw like a box up there?
oh, I'm sorry. I was trying to, this is a building, I'm sorry.
Oh.
I was making it a physical problem, like a word problem, like this is a building, there's a person here going, ah, and so I get the ladder up against the, you see what I'm saying?
Okay.
So just, they're gonna have word problems, but they're always gonna boil down to, oh, there's the triangle, bam. So now it's not, it doesn't matter if this is a building or if this is a cliff edge or whatever. You guys kinda with me?
Yeah.
As long as you can find the right triangle of the problem, you can set up the work to do it. Some problems have more than one right triangle, so we'll do a problem like that in a minute, but, okay. Okay, so, what kind of problem are we currently incapable of doing unless you read the book yourself? This kind of problem. Could be triangle, could be building, blah, blah, blah. And I tell you this is 7, and I tell you this is 4, and I want to know what this angle is. Right? We can set up the correct trig function for that. For some reason, I'm really stuck on what trig function? Sine. What would sine theta be? 4 over 7, take x. But does that tell me what the angle is? No. Are you guys kind of with me?
Yeah, we do.
What if I would have said, I should have done this first, well, let me do it now. Before I tell you how we can solve this, here's a problem we could do. If I told you triangle, I want to know the angle, it's had a rough time, stop it, okay. And I tell you that's 1 and that's 2. What's sine theta in this case? Sine theta is 1/2. So what angle has a sine of 1/2?
30. 33.
Why 30?
Because it's from 0.
Sine likes y.
So it's, yeah.
The output's gonna be small when it's close to x,
Oh.
30. You guys see what I'm saying?
Yeah.
So I don't know how you have it memorized, but if I would have given you a quiz today, it would have been no calculators, and it would have been sine of 60, sine of 180, sine of, or cosine of this, tangent of this, right? You guys are kind of with me?
Yeah.
Okay. That would have been what would have happened. So this would be 30 degrees. Right? Why can't I do that here? Because freaking 4 over 7, I'm not supposed to memorize that. You guys kind of with me? Okay. So, real quick, how would I solve this equation? Square root of theta equals 4/7. Oh, it's squared, right? Incredible. Blah, blah, blah. How would I solve this equation? Theta divided by 3 equals 4/7. So every time I'm going to do the inverse operation, correct? To undo the thing that's there. Okay. So if you have your calculator, what's right above the sign button?
Inverse of sine.
Inverse sign, yeah. Wait. So what I do is I'm going to give myself a little room, and you'll see why. What sucks about, I really need you, I'm sure you guys relate to me, picking like a little word to be a function kind of sucks. It just does. I don't know if you guys are with me on that. You guys ever done logarithms?
Yes.
Log, base, blah, and you're like, why has it got to be a word? right? They have all these stupid jokes about log cannons and whatever. So really what I did on either one of these is I just applied the inverse operation. The inverse of dividing by 3 is multiplying by 3, correct? So what I'm going to do to solve this equation is I'm going to apply the inverse function. How many guys remember what inverse functions do? Like, what would the inverse of the function x plus 2? What's the opposite of that function? What's the inverse of x plus 2? X minus 2. What's the opposite of adding 2? Subtract. Holy shit. So what do inverse functions do? They do the opposite operation. So watch this. Whatever sine did to theta, inverse sine is going to undo it. So you get theta. The same way here, wouldn't these kill each other?
Yeah.
Here, wouldn't these kill each other?
Yes.
Here, they kill each other because they're inverse operations. They do the opposite of what the original did. Yeah.
I think I heard this from like my last class, but I remember like inverses are supposed to like equal like its opposite. in some
Well,
cases.
The word opposite is actually not specific enough but it's supposed to do all the opposite operations. Does it make sense? What's really weird is I just taught this in my pre-calc class this morning. We did inverse functions, but is everybody sorted with me so far? We're not going to get too deep into inverse functions. I just want you to realize you've used them a lot already in your math career. Yes, we're just doing it again. It just sucks. It's a little word. Inverse of sine. So these kill each other. So now what do I do on my calculator? I'll put it up on the overhead. My calculator. What do I do in my calculator? Oh, sorry. Thank you for laughing. Let's see. Welcome.
Are you okay?
I am always just barely okay. True. This is a robust debate to be had. Someday. Okay. So above your sine button lives inverse sine. That's crazy. Just like above your x squared lives square root. So if I hit second sine, see how it gives me inverse sine? It's crazy. And then I just put in there 4 divided by 7. Now, one thing I got to do is going to make sure that I'm in degrees. So let's see what I get. There we go. Crazy sauce.
So do we be like sine inverse equals 34.9? Or I mean.
Or it would be, if it was one
34.85?
place, it'd make it 34.8. If it was two places, it'd be 34.85. Yeah. It depends on, so here I would say something like round the answer to one decimal place, so then it would be 34.8.
Okay. But you make sure we
For the-
specify saying sine inverse, right?
How do you mean?
Like, right, sine
What did we
inverse.
just figure out?
Yeah, we found.
Theta.
Theta. We found
Oh,
theta.
okay.
Theta equals the stuff we put in the calculator. So the angle is 34.8.
5.
Sure. Go in these places. Don't forget that. That's huge. Today we're going to learn radians. I think it's the last thing we'll learn before, the last new thing we'll learn before the test. It's going to be the radian stuff. Right? I've kind of alluded to it. There's the button in there to change from radians to degrees. So we're going to learn what the hell a radian is. Finally.
Today?
Today. It's going to happen.
Yeah.
I love the vote of confidence. Okay. Sure, Jeff. You can do it. All right.
Yay.
Oh, man. Is that all right, guys?
That's so cool.
So real quick, let me see. What if,
I have a quick question.
yeah,
So like, will it ask you like, find the inverse?
no. The kind of problems you'll see is exactly like the one I just gave you. So if I gave you a right triangle and I said that this side was, what do you got, Jeff? 27, and this side is 11, and I want to know what this angle is.
Inverse tan.
You kind of approach it the same way the other problem we did. You first pick what trig function relates to the things I know. Do I give a shit about the hypotenuse in this problem?
No.
You could be all a little triangle, what's your hypotenuse? But for the problem, I don't care, right? So what trig function am I gonna use? Tangent. You could use cotangent, but that sucks because it's not really on the face of my calculator, correct? So you could all day use cotangent, I'm just not going to because it's not got its own dedicated key. You guys with me? So why do that to myself? So what's tangent equal in this case?
7/11.
All right, nobody say a word, everybody solve this. Yeah, don't have a calculator, just at least do the next step up there. Man. Yes.
If you give us such problems, do we have to show our work that we're like switching them? Or
How do you
can we
mean?
just
Oh,
can we just straight
not
up?
really. This would be good work, and then you can go straight to theta, because now you just plug stuff into calculator, right?
Okay.
Yeah. Yeah, where was that? That was the latest stuff. Oh wait, this is this one. Oh, there it is, okay. See you, sorry.
Would it be like you use inverse at any time or?
Anytime you need to, yeah. I mean, there's more to the story of inverses. But right now, we're living inside of a triangle, and triangles have some limitations. The biggest the angle could be would be right before 180, right? You know, it's really wide open triangle with an almost 180 degree. Are you kind of with me? Okay. There's a little more to the story of inverses, but in terms of solving triangles, I can just do this directly. What's the next step up here? Do what? Oh, be careful.
Multiply by 11.
What am I trying to solve for?
Theta.
Theta, right? So why would I load more stuff onto theta? Don't I want to get rid of stuff that's on theta? You see that? How do I kill? What's on theta? What's happening to theta? There's a tangent being taken to theta, correct? Don't I want to kill this guy? So then I can figure out what the hell theta is, right? So what do I do to both sides?
Divide by two?
Multiply by the inverse.
Very quickly, guys, stay with me for a second. This is important. The fact that this symbol is freaking tan, which is a word, sucks. Watch this. If I wanted to solve this, could I divide by the square root? Done. There we go. X is 2 divided by square root symbol.
No.
Does that make any sense?
No.
No. So this does not say, and again, don't, if you thought this, you're fine. You're fine. This is some new shit. So this does not say tangent times theta. Tangent of theta. I love it. So just like that's the square root of x, so I have to apply the inverse function to kill it. How am I going to kill the tangent?
Cotangent.
No. All right, another thing. Beautiful. I love you guys. I love you guys so much. I don't blame you because the choice of inverse function notation is stupid. It just is. I don't know if we were drunk when we came up with it. Not drunk enough. It's one of those two. This symbol means flip, correct? This symbol does not mean flip. It means inverse function. So again, if I had f of x is x plus 2, we said this earlier. What is the inverse function? What's the opposite of adding to? Subtracting to. Did I just flip that?
Yes.
Did I flip it and make it 1 over x plus 2?
Oh.
Nope.
Did the opposite.
This symbol, stupid choice. Dumb. We gotta live with it though. You guys kind of with me? So when I write this kind of thing, it doesn't mean reciprocal. It doesn't just become cosecant, right? No. You guys kind of with me? If I wanted to say reciprocate sine, I'd have to do this. And that means flip sine. Do you guys understand? Some of you guys are like, I didn't even think that the wrong way. Okay, but all right. Some of you guys were, so. I wasn't worried until you said that. Damn it. I hate that. I'm sorry.
So then that would be cosecant then, right?
This would be cosecant all day long.
Okay.
This is the function that does the opposite of what sine does.
So if it's brackets, then you use cosecant, is that what you're saying?
I could have used parentheses. I was just trying to be more emphatic. See how this -1 power is acting on what?
The whole thing.
Sine of x. This notation is the same as this notation, which doesn't mean it's a -1 power. It means it's the inverse function, inverse sine. It's not the -1 power. -1 power means flip. This symbol means inverse function. Do you guys understand? If you understand, it was just a bad choice. You guys see how that was just a bad choice? It was a bad day, but then too many people started doing it, and we're like, oh, shit.
So you're saying that in like the one with the parentheses, that one just switched the sign? Or-
This does the opposite of what sine does. So let's investigate that. What does that mean, Jeff? Dear God.
Yeah.
All right. So what's the sine of 45 degrees?
Rad 2 over 2
Rad 2 over 2. So the inverse sine of rad 2 over 2
equals 45.
is the angle whose sine is this. You think backwards, yes? How do you do square root of 16? What do you actually think to yourself? How do you do that? What times is you think opposite, don't you? What's the opposite of square rooting something? Roughly? Squaring something, correct? So don't you think, what would I square to make 16? Don't you think backwards? So when I see inverse sine of something, I go, what would I take the sine of to get that?
Oh, you mean
Yeah, what angle would I take the sine of to get that? Well, obviously it's freaking...
45.
So it's
Yeah.
the same thing?
so that's what you're saying it's doing.
Say again?
That's what you're saying it's doing.
Yes, this notation does not mean make this cosecant. That would be a completely different answer, right? This notation says undo. What would I take the sine of? It's the opposite of sine. Are you guys at all with me?
Yeah.
So, real quick. If my function is x squared, and I put a 3 in, I get a square out, correct? I get a square number out, right? If I put that number into the opposite function, I get back to what I had before. So what do I ask myself? What do I square to get 3? So here, what do I ask myself? What do I take the sine of to get rad 2 over 2? Now, very quick, is everybody semi-decent with that? You guys see that? Where else? That's not the only answer to this. What other angle would give me a sine of rad 2 over 2?
Cosine.
No. What other angle would make sine rad 2 over 2?
-45.
Where's sine positive? Which quadrants?
Oh, you mean in quadrant 4?
I want to know what angle gives me an output of rad 2 over 2. That's what this is really asking, right?
135?
So one answer is 45, and the other answer,
-135.
no, 135. Not negative.
Oh,
Where's sine positive? First and second, yes, because it likes y. You with me? So, earlier I made a comment that since we lived in a triangle, I didn't have to worry about the other part of the inverse. Inverse could give me multiple answers, yes? In fact, how many real answers does this have? An infinite number. Because can't I just... Could I just add so many 360s to either one of these and it still would work? Are you guys kind of with me?
yeah.
But when I live in a triangle, I of course pick the angle that actually could freaking live in a triangle. Does that make sense? 135, well it could, but definitely not with a 90-degree angle. Are you with me? You guys with me?
Yeah.
Okay. We're physically in the same room with you, Jeff. Okay. Yes?
So,
if I give you an angle, you can take the sine of it, correct?
Okay.
If I ask you what angle gives me a sine of blah, 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 I don't even know the angle. I don't have an angle to put in, correct? So real quick, if I have a sine function, what kind of thing do I put into it? What kind of thing do I put into it? An angle. Is everybody with me? I know that's a little bit vague of a question, but you guys would have. Some kind of angle I put in there, correct?
Yeah.
Alright. Yeah, theta is our normal standard like x that we use to represent an unknown angle. You guys with me? And that would equal some number.
Ratio.
So the inverse sine takes a number and makes it become back to an angle. That's what inverse functions do. They take the output of the first thing, bring it back to what the input was. You guys with me? What's 3 plus 2?
5.
What's 5 minus 2? It took me back to 3. It took me back to where I started. Are you with me? So inverse functions undo what the original function did. So the original function does something to an angle and makes it a number. The inverse will take that number and bring it back to the angle. That's what that work over there was. Right here. Sine of 45 made it rad 2 over 2. So inverse sine of rad 2 over 2 brings it back to freaking 45 degrees. Okay, I like it. Okay. Let me see. Yes, sorry.
At the risk of confusing everyone a little bit more, is there an inverse of a secant and cosecant?
Oh, hell yeah. Of course. Now, real quick, let's talk about this for a second. On your calculator, can you guys do me a favor? If you have your calculator, I'm really sorry, I forgot to bring it. If you have your calculator, if you don't, see if somebody near you is nice enough to let you kind of stare at theirs. Can everybody just do this for me? Inverse tangent of 12. And make sure you're in degrees, right? Does everyone remember how to make sure you're in degrees? Everybody should be, if you're using your own calculator. Yeah, under mode.
85.
What do you get?
85 degrees.
85 point, okay,
Yeah.
degrees. Is everybody with me? Did to me, I'm sorry. All together you sound like. You guys with me so far? Now, that was relatively easy because you see a freaking little inverse tangent button, yes? All right, how would you do inverse cosecant of, what do you got, Jeff? I don't know, 9 over 4. Sure.
1 divided by inverse sine. 9/4.
I'll show you a really cool trick. You ready? All right, let me see if you guys are cool with this. Whatever the angle is, whatever the answer to this is, see if you guys are really with me. What is the cosecant of that angle? Sort of like this. Let me ask you this. Whatever the answer to this is, whatever the answer to that is, what do I get when I square it? You know what it is. Come on.
The number.
Whatever the square root of 11 is, what do I get when I square it? Freaking 11, right? So whatever the shit the angle answer is, what is the cosecant of it? 9/4. I love it. What would the sine be then? So this would become, those are the same answer.
Oh, okay.
Cosecant of an angle gives you a ratio, right? What's the ratio? R to Y. So if I just flip it, now it's related to the sine. Do you guys see that? That's why they only gave us those 3 buttons, because they only had so much room on the damn face of the calculator. And this is exactly. So how would you, what do you guys get when you put that in there, out of curiosity?
26.3.
Alright, sounds about right. 26 point blah blah, okay. What were you about to do, Jeff? Oh, so how would you do inverse cotangent of 4/5?
Inverse tangent 5/4.
Yeah, inverse tangent 5/4. I love it. Because again, the cotangent relates to x over y. If I flip it, y over x, that relates to the tangent. They both talk about the same exact freaking angle. Do you see what I'm saying? The answer is going to be the same, of course, Because that angle makes cotangent 4/5 and it makes tangent 5/4. So it doesn't matter which one of these I do. But to me it matters because that's the only button I got, right? Is that all right? Sorry, I get all excited. Yes.
So how come I can't divide 1 divided by the sine of?
Because it's not related to the reciprocal, that's why. Not, the inverse stuff is not related to the reciprocal.
Yeah, but like to get from cotangent to tangent, right? Like to get from tangent to cotangent, before we do 1 divided by.
Yeah, because we were talking about tangent and cotangent. Now we're talking about inverse cotangent, inverse tangent.
Yeah, but if I want to get from inverse tangent to inverse cotangent, why can't I just do 1 divided by inverse tangent to get
Well, let me think. I think, does it work? Maybe it works. It's been a while since I looked at that. So let's see real quick. What's the inverse? Oh yeah, we can't really check it, can we? Alright. I'll have to think about that. I don't think so. I don't think that would work. This is just the way I always do it, but yeah, they shouldn't work that way, because this isn't tangent, this is inverse tangent, which is its own function in its own right, and it doesn't have all the same properties tangent did. Alright. How you guys feeling? So inverses exist. If you try to do some of the 2-4 homework and they got the inverse stuff going on, now you kind of understand it better. You at least saw the button on your calc better, but you guys all with me? Later this semester, it's going to become important to understand that an inverse function can have many different answers. Because in the future, I'm going to be in a certain quadrant, and I need the answer to be in a certain quadrant. That is going to be like a reference angle. We'll see that later this semester. Right now, they should all live in triangles, which is awesome. Yeah.
Sorry, could you repeat that again? We're gonna learn all the other reference angles?
Say it one more time, sorry.
Are you saying that we're gonna learn all the other reference angles? No.
Yeah, so for example, all right, let me do one quick problem. Do you all agree with me that there is an angle in the third quadrant? There is an angle in the third quadrant that has a sine equal to -2/7. But you might have done a homework problem that's almost exactly that.
Yes.
So everybody agree with me? That would just mean that this is 7 and this is -2. So of course, that's true. But help me out. Again, if you have your calculators, how do I solve this for theta?
Inverse sine.
Inverse sine of both sides.
-2/7.
So these kill each other. What do you get when you plug inverse sine of -2/7? Was it negative? Yeah. You should get negative something.
-16.6.
Yeah. You guys with me? Yeah. And again, this is why I don't really like that the book brought inverse stuff in this early, because I normally like to teach it after we talk about graphs, because it makes a lot more sense when we talk about graphs. But the inverse sine is limited in what it can tell me. It only lives in the first and fourth quadrants. It lives from -90 degrees to 90 degrees. And sure enough, the answer we got isn't it in the fourth quadrant? What'd you get again, I'm sorry?
-16.6.
-16.6 roughly? Okay. Degrees. What quadrant do I know I'm supposed to be in? So how do I get what the angle this is? I take 180 and I add 16.6. That's the reference angle. So it went back 16.6 degrees. That's what it's telling me. But if I know I'm supposed to be over here, I just go 16.6 from 180, so then 196.6. Now help me out real quick. Is everybody kind of with me?
Yeah.
Can you guys real quick, what is sine of 196.6? Just do that directly. I think it's going to be -0.285. Yeah. How do they know that? Because what is -2 divided by 7?
0.2.
I have my divided by 7s memorized. Isn't that? Yeah. You're winning at life, Jeff. It happens often enough, trust me. I didn't do it on purpose, it just happened.
0.6?
Sorry?
196.
196.6, because remember, how did I get there? I just added 16.6,
Because it was before.
because that's a reference angle. Because I know I'm supposed to be in the third quadrant. Inverse sine can only give me certain answers. So in the future of this class, we're gonna take an answer and adjust it.
Okay, so, I got negative 0.285.
And what is negative 2/7?
0.2857.
Is it?
Well, they're not.
Yeah, I know. Why is it not perfect? Because you guys rounded here, right? What was the next place here? You guys still have that?
0.
8.
What?
I got 0.
Oh, 0, yeah.
16.60?
1.
1? Okay. So if you put all the decimals in, it would have been perfect.
Okay,
Rounding, we can see it's close enough.
Yeah.
Okay.
well,
Let me stop for it. So inverse sine, all the inverse trig functions are limited. They can only tell me so many angles. We're the humans, later this semester is gonna become important to like put them in the right quadrants. It doesn't know all that shit. Yeah. You guys okay so far? So right now, the problems you're gonna look at live in a triangle. The angles that you get are angles you can use directly. You don't have to worry about adjusting, but since this came up, I wanted to show you this is in our future. I believe this is, anything else about that? Yeah, good. Good, okay.
and
I don't think
what
there's like,
chapter are we on right now for?
that was 2-4,
2-4?
yeah. 2-5, did I, let's see. Does somebody have the, 2-5 homework problems stuff right there with you? I gave all mine away.
Yeah. For 2.5?
Yes.
Yeah.
What were the assignments? I can't remember if I assigned a certain kind of problem.
So,
I didn't want to, but let's see if I did.
well, you said that we didn't go over 2.5 earlier.
I know, what was the 2-5 homework assignment?
So,
1
1
through
to 10 all.
Okay.
19, 24, 33, 36,
Gotcha.
39.
Understood, okay. So. Alright. So just to make sure you understand, this is nothing we have to know yet. The question came up, so I wanted to answer it. Why don't we have to worry about this? Because we live in triangles, it's restricted. The angle it gives me is the angle I need. In the future, we could be in any quadrant, so I need to be able to adjust it later. Okay. Which is one reason why I really don't like the fact this book introduces inverse sine as early as it does, because I don't have the complete picture to give you yet. We'll all be fine.
And,
Will
you
it be
said,
on the test?
Inverse stuff, yeah, hell yeah. Back stuff, no. Inverse trig, yes, of course. So again, I would give you a problem like this. This is 4, this is 19, and I want to know this angle, right? Right?
Cosine.
Yeah, cosine, inverse cosine, blah, blah, blah. Yes.
so the stuff that you're showing us, they're just angles outside.
They were relative to a question somebody asked, and I warned before I did it that it's nothing we have to worry about yet.
Okay.
But it's like more of the whole picture. So I tried to say earlier, there's more to inverse sine, but then, you know.
Okay.
So we could use, okay, now I get it. Cosine or inverse cosine and we'd be fine, right? For that problem.
Yeah, you use cosine if you know the angle, you use inverse trig if you don't know the angle, right? That's the purpose of inverse trig, is to solve for an angle. If the input of a trig is an angle, the output of an inverse trig is an angle. Because they undo each other. Okay, maybe, okay. So, let's talk about bearing. Oh boy, section 2.5. And this is like if you're in a boat, and let me make sure I do my, okay. So if you're in a boat, or a plane or whatever, and you have to take a certain heading, it's normally called the bearing, right? So here's your regular, news. So if I was at an angle like this, if I'm in a boat in the open water, and I am going at 19 degrees, let's see, how the hell do we say that exactly? I'm 19 degrees away from going which direction exactly? North. So I'm 19 degrees, am I east of north or west of north?
East.
So this would be 19 degrees east of north. You guys with me? Make sure this is the way to look at it, because there's a few different, blah, 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 blah. Where did you even do it? Here we go. Oh, okay. So they just do everything relative to north. Oh, okay. So here's how they would write this, just to be the same way they do it. They write this statement as this. 19 degrees east of north. This is the big reason why I don't like this format. This makes more sense. This one you have to remember. You guys with me? Yeah.
North 19 degrees east.
19 degrees east of north.
19 degrees.
East of north. I really want, so before I answer any questions,
So not how it's written from left to right?
yeah, this is the standard way the book writes it. Are you with me?
Yeah.
Right. Real quick, before I answer any other questions, let me see if you guys are cool with this. What if this is 17 degrees?
E17S.
Yeah, because what am I really close to? I'm 17 degrees away from being purely east. So this would be, let me write it this way first, 17 degrees. Why am I not going perfectly east? Because I'm a little bit south of east, yes? 17 degrees south of east. But the way you write it, the way the book does it, it would be E17S. 17 degrees south of east. Yes?
I think you can't just write like 17 degrees southeast. You could start with whether you're going up or down and then left.
Because we always want to identify 17 degrees with respect to what? So if he said 17 degrees southeast, right? Does that mean this angle or does that mean this angle? Is this 17 or is that 17? Do you see what I'm saying? Okay, good, because that's a beautiful suggestion, but you see why it doesn't really identify it well enough. So if I meant this angle, how would I write this? This would be 17 degrees east of south. So it'll be south 17 degrees east. 17 degrees east of south. Yes?
So if we choose to say E73S.
Oh, sure. Yeah, you can do complementary angles, of course. Another way to write 90 degrees east of north is to write, what's this? 71 degrees north of east, right?
Mhm.
You guys all with me? Okay. All right. Is this different from what you do in your everyday life? Is it really difficult? Is it difficult, or is it just something you don't do every day?
Or something completely new.
Huh?
Or something completely new.
Something completely new. Are you guys with me? Is the math involved in everything I just did? Is it difficult? In fact, there's no math. It's all just labeling, correct? So it's a labeling standard that you just have to get used to.
So,
Yes.
I'm sorry, I'm still kind of confused.
Sure.
So I know you can like make it a triangle, like we can write triangle to make it easier to solve, but
No, all right. So I'm not trying to solve anything.
okay.
I'm just trying to identify to somebody which direction I'm headed. So if I'm going this way,
Yeah.
and I can measure how far off of north I am, how do I communicate that to somebody else who's trying to come out to help me? My boat's on fire, right? And there's a big old shark.
Oh no.
And I'm like, okay, so I want somebody to come help me. I need to tell them which way my boat is drifting so that it actually intercept me. Are you guys with me?
Yeah.
Seems like something you'd want to do. This is purely just telling them which direction I'm going. Why is it not easy to tell what direction you're going in the open ocean? Because you got ocean. So if I can do it relative to something, relative to north, relative to west, relative to east, relative to south, nobody would make a mistake. They know exactly. I can't go, well, I'm right next to the big wave. And so, oh, no, what? I need something relative to something that we all could figure out. I can figure out what true north is. I can then go 19 degrees east of north, and then I can come get you. Does that make sense?
Yeah.
Okay. You guys kind of with me?
Yes.
So it's kind of like backwards, huh? In a sense.
The way they write it, I agree, is backwards. Is that what you mean?
Yeah.
Yeah, I don't like this format, but then again, I'm not a big Bowden guy, so, yes.
The way that I'm memorizing it is like, you're starting it like really
Yeah,
left from
this
right
is the
north.
major, yeah.
Like literally left from right is like north, okay, 19 degrees east.
Yes, so start, I love it. Face north,
Yeah.
move this away from it, kick ass. I love it.
So.
Okay.
So what about that problem then? Like, so,
So, alright, this one, what's the major direction that I'm moving away from?
East.
East. How far am I moving away from it?
17 degrees.
And which direction am I moving away from it?
South.
This one,
So,
South.
south is the major direction. I'm moving 17 degrees east.
Okay. So, okay, we're just.
See, I see southeast is not good enough, right? I want to be more specific, which means I have to reference it to a major direction, one of the 4 cardinal directions, right?
And in the book, don't they say that like usually the first letter has to be either north or south?
Yeah, I'm just generalizing what we could do more generally. I think the book references everything to north and south, but you don't have to.
Okay.
So the book is going to be less general than me. I think you're right. I think they base everything on
North and south.
north and south, which is not necessarily true. Yeah. But yeah, it's even better in the book then. It's less possibilities, right? So in the book, you would never see this.
Yeah. No.
Yeah. So if I was here, the book would actually say, what's this?
South.
73.
So then this would be
S73.
S73E. Yeah.
That's how the book wants it.
Yeah, they usually just start with an NRS.
Yeah. Yes.
So how come the book references the Y side instead of the X, which
It's just a choice.
for referencing?
It's just a choice. I really want this to make sense. Almost every damn thing that you're taught, the concept is true. The choice we made with the symbols to represent it, complete choice, right? Yes.
So
Just like the inverse sign. The inverse, the negative one, bad choice, but it was a choice.
So let's say on a test you could put it either way, either how the book put it or how you put it for the like.
I'm cool with it, because it would tell me where the hell you're going, right? Yeah. Because I certainly have done this before, but this book wants to keep it referenced to the y-axis for their own reasons. Okay. If anyone's a boater, maybe that's the way it's done, but I'm not a boater.
maybe they just love sign. Maybe they just love sign.
Yeah, sort of like me today. Today is a sign kind of day. The other kind of problems that are in section 2.5. What time we got? We got some time.
And
Okay.
then we're gonna move on to chapter 3, just where we're gonna.
Yeah, we're gonna get into a little bit in chapter 3 as well.
Okay.
So let me give you an example problem directly from the book here. Maybe I'll try not to do one of your homework problems.
You wanna borrow mine?
What's up?
You wanna borrow my homework sheet? Is that what you want to worry about?
No, if I happen to, then just enjoy it. I'm gonna do number 36.
Number 36 for 2.5?
2.5, yeah.
Okay.
Is that something I assigned?
Yeah.
Yeah.
Okay, so I'll do 35. If that's also signed, I don't care. It's awesome getting old. It's 392 feet. Here, do this for yourself, Jeff. So I'm looking at this problem here. Where's my others? Oops, no, that one. Yeah, there it is. Ooh, look at it. See everything. It's crazy. So I'll just do it up whenever. So, instead of just redrawing the damn thing, I just look at it directly. Technology. All right. So I need to figure out this. You see how this is a little more involved? This is what I said earlier, there could be more than one right triangle. Can anyone tell me how many right triangles are up in there?
Two.
One.
Two.
There's two.
There's a big one. There's a little one.
Okay.
You guys see it? Okay. And if I want to figure out what H is, let me see if you guys can. Which side do I not give a shit about? That's a really good place to start. Which side do I not care about? Hot triangles, I love it. So we let go of that. So we care about the X side and the H. Obviously, we care about this side because that's the question, right?
Mm.
What side here do I know nothing about? I don't know the side, the X side of the little triangle, right?
Yeah.
So let me just call it X. That's right. Right. Give it a name so I can do stuff to it instead of just a blank spot, right? Let me stop for a minute. So that's all I've done so far is I identified what side do I not care about. Very often there's something you don't care about, so just let it go and then give variables to everything you do care about. Look at the little triangle. Ignore this is what I'm saying, right? There's a right triangle right there, right? What can you set up? What trig function would relate? Tangent. Now what sucks about it though? How many unknowns are there?
Two.
Shit. Which is why there's two right triangles. So here's a really good question for you guys. Do you remember how to solve a system of equations?
Yeah.
Sounds familiar.
Sounds familiar? All right, so little side note. Little side note. What time is it? Are you going to make it to radians, Jeff? I don't know, Jeff. I needed to solve this system of equations. Let's see if I can make one that works. Would that be good? Yeah.
Like piecewise kind of thing?
No, it's not pieces. I think it's 4. Okay, let's see if Jeff made one that works. If I wanted to solve that system of equations, oh shit. Yes.
Multiply the first.
Total, but I'm going to do it a different way. Actually, the way you're saying, I like it, but the second way is going to be more applicable to this. So I could multiply the first one by 2 and then add these together because my x's die. Because what's the problem with either one of these alone? Too many freaking variables. The number of variables is too damn high, right? So I could directly kill them, or I could take the first guy and solve it for x. And then I'll know what x is, sort of, right? How do I solve the first guy for x? Yeah, so I have x equals 11 minus 3y. Is that cool? That's new information. How can I rewrite the second guy then? The second guy is negative 2 times x.
Negative 2 times 11 minus 3y plus 7.
Is this coming back to anybody? This is, incredibly enough, we call this the substitution method. Because it substituted this in for what it is. Can you solve this now?
Yeah.
What do I get there?
Negative 22.
6y.
So I get 13y, and I can add a 22 over, right?
Yes, you can.
26, so I get y is 2, right? And since I know y, x will be 11 minus 3 times y. X is 5. Crazy. All right, Jeff, that's great, man. There's no trig in there. I know. So real quick. Little triangle. Oh shit. Oh, here. Oh, I caught it. Good. Little triangle. What trig function can you set up for the little triangle? Yeah, tangent. So one equation I can set up. Tangent of
49.2
49.2 equals
h over x.
yeah, h over x. Is that cool?
Yeah.
Okay, I like it. Now look at the big ass triangle. so now I'm looking at this triangle, correct? Because doesn't it also have the thing I want to know in it?
Yeah.
So if I use tangent again, tangent of what? 29.5 equals
H over
h over,
392 plus x.
yes. Is this straightforward? So far it is. Now you have to solve it. So far, all we did was, I don't know if you guys will agree, a very minimal effort. It's just, we know what tangent is, so I just made the ratios. I barely did anything here. Go Jeff. Now what do I want to solve? What do I want to figure out? What's the whole point of the problem?
Figure out h.
I want to know what h is. So which letter do I not give a shit about? At least in this problem. X. Does everybody understand what I just said? I don't care what x is. That's not the point of the problem. The problem wants me to figure out what h is, correct? You guys with me? So what I do then is I pick the one that's easier to solve, and I solve it for the letter I don't care about. So how do I solve that first one for x?
X equals h over 10.
Yeah, so the really cool thing is, I don't remember if I showed you guys this, but you can just switch these. Could you multiply it by x? And we can, and then can you divide by tangent?
Yeah.
Don't these just switch places? So you get x equals h over tangent 49.2, and then you can take this, plop it in there, right? This is an example of one of the more difficult problems, I would say. And you're all like, oh good. Because you don't want this one to be, oh, this is a simple problem. I would do a little work with number 2 first. Say again?
Oh, sorry, is that 10 right there above?
Tangent of 49.2.
Okay, yeah.
If I took number 2 and I did the same thing, shaboom, yes? So then I would get 392 plus x equals h over tangent 29.5, right? Excuse me. Then I could take this and put it here. And then I can solve for h. It's the same thing we just did over there. It's just got a little more stuff around it, right? So I took one equation, solved it for the letter I don't care about. Then I can plug that into the other equation. You move this over here. So I've given up on my radians. We're not going to make it to radians today. There's no way. I know. I'm sorry. By the way, just in case somebody's going to leave early, I got the practice test I'm going to give you in a minute. Huh? There's nothing shit about that. I'm never going to look at it. It's a study guide. So just bringing this over here. Let's see. So now I've got that, and I've got this. Where's this? Where'd it go? Oh, there it is. So now I can put this. This is what x is. So, there's a lot to write, and what I'm writing is not pretty. It's not like 2, it's freaking h over tangent of 49.2. It's not pretty to look at. There should be little degrees everywhere, but it's all right. You guys all with me? It's a lot to write. It's not nice to look at, but there wasn't a lot of work that happened. You've got to differentiate between what looks horrible and what is horrible. This looks horrible. But what did I do? I just took one, solved it for x, and then just took that and shoved it in there. That's all I've done so far. Now, tell me, we're trying to solve for h, correct? How do you solve any equation in the universe for h? You get everything that has h in it on one side and all the other stuff on the other, correct? The most basic algebra idea, yes? What's the only term that has h in it that's not with the other term? Which term is in the wrong place? All the h's should be together by themselves on one side. So which thing do I need to move?
So h over tangent.
This guy.
Yeah.
If I subtract him over, oops, subtract him over, yeah, sorry. So this will be this minus this guy. I could rewrite this as cotangent, but I'm not going to, because there is no cotangent button, so, yeah.
Can you like take the h out of?
That's what we're gonna do, yeah. Whenever you have more than one variable, you actually don't. Because since it's in both terms, what can I do with it? Take it out.
Take it out.
They're not like terms, well, they are sort of, but I can take an h out. And then I divide by that. Because all this is a number, do you guys agree? Whatever the shit this is, it's a number. I divide by that number and I get what h is, right? So in your calculator, how the hell am I gonna do that? Well, let's see. In my calculator, I'm gonna put, what was it, 392 divided by parenthesis 1 divided by tangent, what was it? 29.5. See how I close that parenthesis that it opened for me? Minus 1 divided by tangent of, what was the other one? 49.2?
Did you say how to get rid of the h?
Oh, I didn't get rid of it. I got it by itself. So if I divide by this, isn't the h by itself? Then h equals number, that's the answer, because they want to know what the hell h is, right? So if I divide by this, which I just threw in here, 392 divided by this, right? Okay, now I need to know the answer. There we go. 433 point whatever tall. I think you all would agree that was a longer problem. And again, I don't know how many of you guys really trust what I just said. I think the thing that gets students down is just the amount of writing. And what you're writing does not look nice. But if you really think about the work we did, there wasn't much. It was a bunch of writing stuff that I really wouldn't want to look at. Okay, maybe that's one of the harder problems you would get in that section, yeah.
So when you're dividing by a fraction, could you just have done 392 times 10, 29.5 minus?
What? Do it again?
Because you know how you're doing like 392.
Oh, no, you gotta be careful. You can't flip pieces of a subtraction problem.
Well, yeah.
You can't.
Okay.
So what did you put in there? Did you get
Well,
the
I
same
did
number?
what you did. I'm just
Okay,
making.
okay. Go for it, try.
I'm-
You never know, I could be insane, could be wrong. So let me give you the practice test. I'll point out the problems that we can't do because they're from the radian sections.
Ah.
Thank you.
Sure. By the way, on the actual test, I'll give you more room. This is just a practice test, I figure you your own paper. Couple things about the practice test. I will have the answer key next time I see you. So you do not have to turn this in. You do not have to do this. Your priority is homework. This is at least just to give you an idea of how I like to set on my test, what kind of questions I like to ask. You with me? Very first time I taught, my students said, "Hey, what's your test look like?" And I said, "I don't know." So the very first practice test I made was literally a practice test for me. So I've just done it ever since. What was I gonna say? Oh yeah, real quick. Number 10, very obviously, you don't have to worry about for this next test. It'll be on the next test after this. Are you guys with me? Number 10 talks about radians. Do you see that? Also, number 7, C and D. I know you all know the symbol pi. Do you see that symbol pi in number 7? That relates most often to radians, and it makes sense. Radians are a physical measurement of a circle instead of a made-up bullshit degree. I talked to you guys about we just made that shit up. It could have been 400, it could have been 20. Radians are physical measurements. They make more sense. They're not just some made-up shit. Sorry. I just wanted to talk about it today. It's too bad, Joe. Is everybody with me? So number 7, CD, number 10. I think everything else is something you need to be able to do, yes. And a couple of these I referenced the book just because I didn't want to make a brand new problem myself. I just said, oh, I'll steal from the book a bit. Yeah.
Are we not learning radians on Monday?
Say what?
Monday, are we gonna learn chapter 3 Monday, or are we just gonna review?
So again, good. This is our first test. So like it says on the syllabus, the day before a test is nothing but review.
Okay.
So that's why I had to give up on radians. I'm not going to do it Monday because they don't. So again, when is like homework due? 2 classes later, right? So that's why I try to have the day before the test is just review, because then the homework we did the day before that is due 2 classes later on the day of the test.
So,
Method to madness.
so will any of chapter 3 be due before chapter?
No. So chapter 3 is going to be on the next test.
Okay.
So not
Or I
like
might
that.
give it its own quiz. I'll figure it out. Yeah.
So chapter 3 won't be this upcoming test.
Chapter 3 will not be on this test. You do not have to do chapter 3 homework yet.
Okay.
So what homework will be due all the way through T5? 2-5. I'm never going to make you turn in homework that I haven't talked about yet. That would be the next level of evil, which I'm still working on.